In gambling parlance, making a book is the practice of laying bets on the various possible outcomes of a single event. The term originates from the practice of recording such wagers in a hard-bound ledger, the book, and gives the English language the term bookmaker for the person laying the bets and thus making the book, making a book, and the notion of over-round. A bookmaker strives to accept bets on the outcome of an event in the right proportions so that he makes a profit regardless of which outcome prevails. See Dutch book and coherence. Philosophical gambling strategy. This is achieved primarily by adjusting what are determined to be the true odds of the various outcomes of an event in a downward fashion, i.e., the bookmaker will pay out using his actual odds, an amount which is less than the true odds would have paid, thus ensuring a profit. The odds quoted for a particular event may be fixed but are more likely to fluctuate in order to take account of the size of wagers placed by the bettors in the run-up to the actual event, e.g., a horse race. This article explains the mathematics of making a book in the simpler case of the former event. For the second method, see Paramutual Betting. It is important to understand the relationship between odds and relative probabilities. Thus, odds of A, B, or A to B, represent a relative probability of B, A plus B, e.g., 6 to 4. 6 to 4 is 4. 6 plus 4 equals 4/10 equals 0.4, or 40%. A relative probability of X represents odds of 1 minus X. X, e.g., 0.2 is 1 minus 0.2. 0.2 equals 0.8, 0.2 equals 4 over 1. 4 to 1. 4 to 1. Example. In considering a football match, the event, that can be either a home win, draw, or away win, the outcomes, then the following odds might be encountered to represent the true chance of each of the three outcomes: home, evens, draw. 2 to 1, away, 5 to 1. These odds can be represented as relative probabilities, or percentages by multiplying by 100, as follows. Evens, or 1 to 1, corresponds to a relative probability of 1/2. 50%. 2 to 1 corresponds to a relative probability of 1/3. 33 and a third percent. 5 to 1 corresponds to a relative probability of 1/6. 16 and 2/3%. By adding the percentages together, a total book of 100% is achieved, representing a fair book. The bookmaker, in his wish to avail himself of a profit, will invariably reduce these odds. Consider the simplest model of reducing, which uses a proportional decreasing of odds. For the above example, the following odds are in the same proportion with regard to their relative probabilities: 3, 2, 1, home, 4 to 6, draw, 6 to 4, away, 4 to 1. 4 to 6 corresponds to a relative probability of 3/5. 60%. 6 to 4 corresponds to a relative probability of 2/5. 40%. 4 to 1 corresponds to a relative probability of 1/5. 20%. By adding these percentages together, a book of 120% is achieved. The amount by which the actual book exceeds 100% is known as the over-round bookmaker margin, or the figure-ish, or vig. It represents the bookmaker's expected profit. Thus, in an ideal situation, if the bookmaker accepts £120 in bets at his own quoted odds in the correct proportion, he will pay out only £100, including returned stakes, no matter what the actual outcome of the football match. Examining how he potentially achieves this. A stake of £60.00 at 4 to 6 returns £100.00 exactly, for a home win. A stake of £40.00 at 6 to 4 returns £100.00. Exactly. For a drawn match, a stake of £20.00 at 4 to 1 returns £100.00. Exactly. For an away win, total stakes received £120.00 and a maximum payout of £100.00 irrespective of the result. This £20.00 profit represents a 16 2/3% profit on turnover. 20.00 times 100 and 120.00. In reality, bookmakers use models of reducing that are more complicated than the model of the ideal situation. Overround on multiple bets. When a punter, better, combines more than one selection in, for example, a double, treble or accumulator, then the effect of the overround in the book of each selection is compounded, to the detriment of the punter in terms of the financial return compared to the true odds of all of the selections winning, and thus resulting in a successful bet. To explain the concept in the most basic of situations, an example consisting of a double made up of selecting the winner from each of two tennis matches will be looked at. In match 1 between players A and B, both players are assessed to have an equal chance of winning. The situation is the same in match 2 between players C and D. In a fair book in each of the matches, i.e., each has a book of 100%. All players would be offered at odds of evens. However, a bookmaker would probably offer odds of 5 to 6, for example, on each of the two possible outcomes in each event. Each tennis match. This results in a book for each of the tennis matches of 109.09%, calculated by 100 times 6/11 plus 6/11, i.e., 9.09% overround. There are 4 possible outcomes from combining the results from both matches. The winning pair of players could be AC, AD, BC or BD. As each of the outcomes for this example has been deliberately chosen to ensure that they are equally likely, it can be deduced that the probability of each outcome occurring is 1/4 or 0.25, and that the odds against each one occurring is 3 to 1, 3/1 or 3 to 1. A bet of 100 units, for simplicity, on any of the winning combinations would produce a return of 100 times 3/1 plus 1 equals 400 units. As detailed below, the actual return on any of these winning doubles is obtained by multiplying stake times odds plus 1 from each single bet together. Thus, for a stake of 100 units we get a return of 100 times 5/6 plus 1 times 5/6 plus 1 equals 336.11 units, representing odds of 2.3611 minus 1, which is far less than the true 3 to 1. Odds of 2.3611 minus 1 represent a percentage of 29.752%. 103.3611. And multiplying by 4 for the total number of equally likely outcomes gives a total book of 119.01%. Thus, the overround has slightly more than doubled by combining two single bets into a double. In general, the combined overround on a double, OD, expressed as a percentage, is calculated from the individual books B1 and B2, expressed as decimals, by OD equals B1 times B2 times 100 minus 100. In the example we have OD equals 1.0909 times 1.0909 times 100 minus 100 equals 19.01%. This massive increase in potential profit for the bookmaker, 19% instead of 9% on an event. In this case the double is the main reason why bookmakers pay bonuses for the successful selection of winners in multiple bets. Compare offering a 25% bonus on the correct choice of 4 winners from 4 selections in a Yankee. For example, when the potential overround on a simple fourfold of races with individual books of 120% is over 107%. A book of 207%. This is why bookmakers offer bets such as Lucky 15, Lucky 31 and Lucky 63, offering double the odds for 1 winner and increasing percentage bonuses for 2, 3 and more winners. In general, for any accumulator bet from 2 to I selections, the combined percentage overround of books of B1, B2, by given in terms of decimals, is calculated by B1 times B2 times by times 100 minus 100. E.g., the previously mentioned fourfold consisting of individual books of 120%, 1.20, gives an overround of 1.20 times 1.20 times 1.20 times 1.20 times 100 minus 100 equals 107.36%. Settling winning bets. In settling winning bets, either decimal odds are used or 1 is added to the fractional odds. This is to include the stake in the return. The place part of each way bets is calculated separately from the win part. The method is identical, but the odds are reduced by whatever the place factor is for the particular event. See Accumulator below for detailed example. All bets are taken as win bets unless each way is specifically stated. All show use of fractional odds. Replace fractional odds plus 1 by decimal odds if decimal odds known. Non-runners are treated as winners with fractional odds of 0. Decimal odds of 1. Fractions of pence in total winnings are invariably rounded down by bookmakers to the nearest penny below. Calculations below for multiple bet wages result in totals being shown for the separate categories, e.g., doubles, trebles, etc., and therefore overall returns may not be exactly the same as the amount received from using the computer software available to bookmakers to calculate total winnings. Singles. Win single, e.g., £100 single at 9 to 2. Total staked equals £100. Returns equals £100 times 9 halves plus 1. Equals £100 times 5.5 equals £550. Each way single, e.g., £100 each way single at 11 to 4. 1/5 odds a place. Total staked equals £200. Returns. Win equals £100 times 11 quarters plus 1. Equals £100 times 3.75 equals £375. Returns. Place equals £100 times 11/20 plus 1 equals £100 times 1.55 equals £155. Total returns if selection wins equals £530. If only placed equals £155. Multiple bets. Each way multiple bets are usually settled using a default win-to-win, place-to-place method, meaning that the bet consists of a win accumulator and a separate place accumulator. Note: a double or treble is an accumulator with 2 or 3 selections respectively. However, a more uncommon way of settling these type of bets is each way or leech way, which must normally be requested as such on the betting slip, in which the returns from one selection in the accumulator are split to form an equal stake. Each way bet on the next selection and so on until all selections have been used. The first example below shows the 2 different approaches to settling these types of bets. Double, e.g., £100 each way double with winners at 2 to 1, 1/5 odds a place, and 5 to 4, 1/4 odds a place. Total staked equals £200. Note: win to win. Place to place will always provide a greater return if all selections win, whereas each way or leech way provides greater compensation if one selection is a loser, as each of the other winners provide a greater amount of place money for subsequent selections. Treble, e.g., £100 treble with winners at 3 to 1, 4 to 6 and 11 to 4. Total stake equals £100. Returns equals £100 times 3 over 1 plus 1 times 4/6 plus 1 times 11 quarters plus 1 equals £2,500. Accumulator, e.g., £100 each way 5-fold accumulator with winners at evens, 1/4 odds a place, 11 to 8, 1/5 odds, 5 to 4, 1/4 odds, 1 to 2, all up to win, and 3 to 1, 1/5 odds. Total stake equals £200. Note: all up to win means there are insufficient participants in the event for place odds to be given, e.g., 4 or fewer runners in a horse race. The only place, therefore, is first place, for which the win odds are given. Returns: win 5-fold equals £100 times 1 over 1 plus 1 times 11/8 plus 1 times 5/4 plus 1 times 1/2 plus 1 times 3 over 1 plus 1 equals £6,412.50. Returns: place 5-fold equals £100 times 1/4 plus 1 times 11/40 plus 1 times 5/16 plus 1 times 1/2 plus 1 times 3/5 plus 1 equals £502.03. Total returns equals £6,914.80. Full cover bets: Trixie, Yankee, Trixie, Yankee, Canadian, Heinz, Super Heinz and Goliath form a family of bets known as full cover bets which have all possible multiples present. Examples of winning Trixie and Yankee bets have been shown above. The other named bets are calculated in a similar way by looking at all the possible combinations of selections in their multiples. Note: a double may be thought of as a full cover bet with only 2 selections. Should a selection in one of these bets not win, then the remaining winners are treated as being a wholly successful bet on the next family member down. For example, only 2 winners out of 3 in a Trixie means the bet is settled as a double. Only 4 winners out of 5 in a Canadian means it is settled as a Yankee. Only 5 winners out of 8 in a Goliath means it is settled as a Canadian. The place part of each way bets is calculated separately using reduced place odds. Thus, an each way Super Heinz on 7 horses with 3 winners and a further 2 placed horses is settled as a win Trixie and a place Canadian. Virtually all bookmakers use computer software for ease, speed and accuracy of calculation for the settling of multiples bets. Full cover bets with singles. Patent, Lucky 15, Lucky 31, Lucky 63 and higher lucky bets form a family of bets known as full cover bets with singles which have all possible multiples present together with single bets on all selections. An examples of a winning patent bet has been shown above. The other named bets are calculated in a similar way by looking at all the possible combinations of selections in their multiples and singles. Should a selection in one of these bets not win, then the remaining winners are treated as being a wholly successful bet on the next family member down. For example, only 2 winners out of 3 in a patent means the bet is settled as a double and 2 singles. Only 3 winners out of 4 in a lucky 15 means it is settled as a patent. Only 4 winners out of 6 in a lucky 63 means it is settled as a lucky 15. The place part of each way bets is calculated separately using reduced place odds. Thus, an each-way lucky 63 on 6 horses with 3 winners and a further 2 placed horses is settled as a win patent and a place lucky 31. Algebraic interpretation. Returns on any bet may be considered to be calculated as stake unit times odds multiplier. The overall odds multiplier is a combined decimal odds value and is the result of all the individual bets that make up a full cover bet, including singles if needed. E.g., if a successful £10 Yankee returned £461.35, then the overall odds multiplier is 46.135. If A, B, C, D represent the decimal odds, i.e., fractional odds plus 1, then an OM can be calculated algebraically by multiplying the expressions A plus 1, B plus 1, C plus 1, etc. together in the required manner and subtracting 1. If required, decimal odds plus 1 may be replaced by fractional odds plus 2. Examples: 3 selections with decimal odds A, B and C, expanding A plus 1, B plus 1, C plus 1, algebraically gives ABC plus AB plus AC plus BC plus A plus B plus C plus 1. This is equivalent to the OM for a patent. Treble, ABC, doubles, AB, AC and BC, singles, A, B and C, plus 1. Therefore, to calculate the returns for a winning patent, it is just a case of multiplying A plus 1, B plus 1, and C plus 1 together and subtracting 1 to get the OM for the winning bet, i.e., OM equals A plus 1, B plus 1, C plus 1, minus 1. Now multiply by the unit stake to get the total return on the bet. E.g., the winning patent described earlier can be more quickly and simply evaluated by the following. Total returns equals £2 times 4/6 plus 2 times 2/1 plus 2 times 11/4 plus 2 minus 1 equals £99.33. Ignoring any bonuses, a 50p each way lucky 63. Total stake £63. With 4 winners: 2 to 1, 5 to 2, 7 to 2, all 1/5 odds a place, and 6 to 4, 1/4 odds a place, and a further placed horse, 9 to 2, 1/5 odds a place, can be relatively easily calculated as follows. Returns. Win part equals 0.50 times 2/1 plus 2 times 5 halves plus 2 times 7 halves plus 2 times 6/4 plus 2 minus 1 equals £172.75, or more simply as 0.50 times 4 times 4.5 times 5.5 times 3.5 minus 1. Returns. Place part equals 0.50 times 2/5 plus 2 times 5/10 plus 2 times 7/10 plus 2 times 6/16 plus 2 times 9/10 plus 2 minus 1 equals £11.79, or more simply as 0.50 times 2.4 times 2.5 times 2.7 times 2.375 times 2.9 minus 1. Total returns equals £184.54. For the family of full cover bets that do not include singles, an adjustment to the calculation is made to leave just the doubles, trebles and accumulators. Thus, a previously described winning £10 Yankee with winners at 1 to 3, 5 to 2, 6 to 4 and evens has returns calculated by £10 times 1/3 plus 2 times 5 halves plus 2 times 6 quarters plus 2 times 1 over 1 plus 2 minus 1 minus 1/3 plus 1 plus 5 halves plus 1 plus 6 quarters plus 1 plus 1 over 1 plus 1 equals £999.16. In effect, the bet has been calculated as a lucky 15 minus the singles. Note that the total returns value of £999.16 is a penny higher than the previously calculated value, as this quicker method only involves rounding the final answer, and not rounding at each individual step. In algebraic terms, the OM for the Yankee bet is given by OM equals A plus 1, B plus 1, C plus 1, D plus 1, minus 1 minus A plus B plus C plus D. In the days before software became available for use by bookmakers and those settling bets in licensed betting offices, LBOs, this method was virtually de rigueur for saving time and avoiding the multiple repetitious calculations necessary in settling bets of the full cover type. Settling other types of winning bets. Up and down. Round robin. A round robin with 3 winners is calculated as a Trixie plus 3 up and down bets with 2 winners in each. A round robin with 2 winners is calculated as a double plus 1 up and down bet with 2 winners plus 2 up and down bets with 1 winner in each. A round robin with 1 winner is calculated 2 up and down bets with 1 winner in each. Flag and super flag bets may be calculated in a similar manner as above using the appropriate full cover bet. If sufficient winners, together with the required number of 2 winner and 1 winner up and down bets. Note: expert bet settlers before the introduction of bet settling software would have invariably used an algebraic type method together with a simple calculator to determine the return on a bet. See below. Algebraic interpretation. If A, B, C, D represent the decimal odds, i.e., fractional odds plus 1, then an odds multiplier OM can be calculated algebraically by multiplying the expressions A plus 1, B plus 1, C plus 1, etc. together in the required manner and adding or subtracting additional components. If required, decimal odds plus 1 may be replaced by fractional odds plus 2. Examples. See also. Statistical Association Football Predictions. Glossary of bets offered by UK bookmakers. Notes. Sydney. C. 1976. The Art of Legging. Maxline International. Sydney. C. 2003. The Art of Legging. The History, Theory, and Practice of Bookmaking on the English Turf. 3rd edition. Rotex Publishing 2003. 224 pp. ISBN 9781872254067. Definitive, and extensively revised and updated 3rd edition on the history, theory, practice and mathematics of bookmaking, plus the mathematics of off-course betting, bets and their computation and liability control. Further reading. Finding an Edge. Ron Loftus. USSC North Charleston. Create Space. 2011. 144 pp. How to Make a Book. Phil Bull. London. Morrison and Gibb Limited. 1948. 160 pp. The Book on Bookmaking. Ferda Rombola. California. Romford Press. 1984. 147 pp. ISBN 978-0-93553637-9. The Art of Bookmaking. Malcolm Boyle. High Stakes Publishing 2006. Secrets of Successful Betting. Michael Adams. Raceform. 2002. The Mathematics of Games and Gambling. Edward W. Packle. Mathematical Association of America. 2006. The Mathematics of Gambling. Edward Doe. Thorpe. L. Stewart. 1984. Maximine Hedges. Jean-Claude Dedarian. Mathematics Magazine. Volume 51. Number 3. May. 1978. Pages 188 to 192. Carnap and de Finetti on bets and the probability of singular events. The Dutch Book Argument Reconsidered. Klaus Heilig. The British Journal for the Philosophy of Science. Volume 29. Number 4. December. 1978. Pages 325 to 346. Tests of the efficiency of racetrack betting using bookmaker odds. Ron Bird. Michael McRae. Management Science. Volume 33. Number 12. December. 1987. Pages 152 to 156. Why is there a favorite long-shot bias in British racetrack betting markets? Leighton Vaughan Williams. David Patton. The Economic Journal. Volume 107. Number 440. January. 1997. Pages 150 to 158. Optimal Determination of Bookmakers' Betting Odds. Theory and Tests. By John Fingleton and Patrick Waldron. Trinity Economic Paper Series. Technical Paper No. 96 9ths. Trinity College. University of Dublin. 1999. Odds that don't add up. Quote. Mike Fletcher. Teaching Mathematics and Its Applications. 1994. Volume 13. Number 4. Pages 145 to 147. Information. Prices and efficiency in a fixed odds betting market. Peter F. Pope. David A. Peel. Economica. New Series. Volume 56. Number 223. August. 1989. Pages 323 to 341. A Mathematical Perspective on Gambling. Molly Maxwell. MIT Undergraduate Journal of Mathematics. Volume 1. 1999. Pages 123 to 132. Probability Guide to Gambling. The Mathematics of Dice. Slots. Roulette. Baccarat. Blackjack. Poker. Lottery and Sport Bets. Kathleen Barbeau-Anu. Inforum. 2006. 316 pp. ISBN 973-875203-5. Optimal Price Setting in Fixed Odds Betting Markets Under Information Uncertainty by Vasily K. Makropoulou of Athens University of Economics and Business and Raphael N. Markelos of Loughborough University.